Hello, everyone, and welcome. Just take a moment and look around you. Everything you see, the colors, the shapes, this screen right in front of you, it's all possible because of one of the most beautiful forms of energy in nature. Today, we're going to explore the wonderful world of light. But have you ever really stopped to wonder, how do we actually see things? It seems so simple, doesn't it? The secret, of course, is light. Think of it like a messenger. It starts from a source, like the sun or a bulb, bounces off an object, say a book, and then travels right into our eyes. Understanding this journey helps us understand everything, from shadows and reflections to how we see the world itself.
So here's our plan for today's journey. First, we'll see how light travels in a super straight path. Then, we'll find out what happens when it bounces off things, which will lead us to mirrors. After that, we'll see how light can bend, we'll uncover the secrets of a rainbow, and finally, we'll see how all this science is used in our everyday lives. So are you ready? Let's begin. All right, Section 1. Before we can get into the fun stuff like mirrors and rainbows, we need to understand the number one rule of light, how it travels. Once you get this, believe me, everything else will just fall into place. Okay, first things first. Some objects in the universe produce their own light. Think of the sun, a torch, or a burning candle. We call these luminous objects. But most things around us, like your table, your book, even the moon at night, they don't have their own light. They are non-luminous. So why do we see them? Well, because they are reflecting light from a luminous source into our eyes. Now, here's a big scientific term, but don't worry, it's very simple. Rectilinear propagation. It's just a fancy way of saying that light always travels in a straight line. These straight paths that light takes are called rays. And we can even prove this with a simple experiment. Imagine you have a lit candle. If you look at it through a straight pipe, you can see the flame perfectly, right? But now, what happens if you take a bent pipe? Can you see the flame anymore? No! That's because the light from the candle travels in a straight line and gets blocked by the bend in the pipe. A simple and powerful proof. You know what? This straight line rule is the exact reason we have shadows. When light is traveling and an opaque object, that's an object light cannot pass through, gets in its way, it blocks the path. The dark patch formed behind the object, where the light couldn't reach, is what we call a shadow. So we know light travels straight, but what happens when it hits a surface? Well, it bounces. Just like when you throw a ball at a wall, it bounces back. This bouncing of light has a special name, and it's called reflection. Now, almost every surface reflects light, but some do it better than others. A smooth and shiny surface, like a mirror, or even the still water of a lake, is excellent at reflecting light. And it's this perfect reflection that allows us to see a clear image of ourselves. Now, this bouncing isn't random. It follows two very strict rules, which we call the laws of reflection. The most important thing for you to remember is the second law. The angle at which light hits a surface is always equal to the angle at which it bounces off. Angle in equals angle out. It's a perfect, predictable bounce every single time. Now that we know the rules of reflection, we can finally understand the magic behind mirrors. We'll start with the flat or plane mirror, like the one in your home, and then we'll look at some really interesting curved mirrors. Just think about your reflection in the mirror this morning. Was it upside down? No, it was upright. Was it bigger or smaller than you? No, it was the same size. And it looked like it was inside the mirror, at the same distance behind it as you were standing in front. But there's one tricky part. If you raise your right hand, your reflection raises its left hand. This left-right reversal is called lateral inversion. But hey, not all mirrors are flat. Some are curved. And you know what? You probably have the perfect example in your kitchen right now. A shiny steel spoon. The inner part, which is curved inwards, acts like one type of mirror, and the outer part, which bulges outwards, acts like another. Let's compare them. A concave mirror, like the inside of the spoon, brings light rays together, or converges them. This is why it can make things look bigger. A convex mirror, like the back of the spoon, does the opposite. It spreads the light rays out or diverges them. This makes the image smaller, but it also gives you a wider view of your surroundings. All right, so we've learned that light travels in a straight line and that it can bounce. But light has one more amazing trick. It can bend. This bending happens when light passes from one material into another, for example, from air into glass.
And we have created special pieces of glass called lenses just to make light bend in useful ways.
And just like mirrors, there are two main types of lenses. A convex lens is thicker in the middle. It converges light rays to a single point, which is exactly how a magnifying glass works. On the other hand, a concave lens is thinner in the middle. It does the opposite. It diverges the light rays, spreading them out and making things look smaller.
Now, for the most beautiful part of our journey. When we combine what we've learned about light traveling and bending, we get to understand one of nature's most spectacular shows. Let's talk about rainbows. Let me ask you a question. What is the color of sunlight? We all think it's white, or maybe a bit yellow. But here's an amazing secret. White light is not a single color at all. It's actually a mixture of 7 different colors, all combined together. So after it rains, when sunlight passes through millions of tiny water droplets hanging in the air, each droplet acts like a tiny prism. It takes the white light and splits it into its 7 component colors. This splitting is called dispersion, and this creates that beautiful arc of colors in the sky that we call a rainbow. The 7 colors always appear in the same order: violet, indigo, blue, green, yellow, orange, and red. And you can remember this order with the simple name Vib Jor. Now, all this science isn't just for textbooks. The principles of reflection and bending of light are used in many things that we use every single day, often without even realizing it. Remember the concave mirror, the one that converges light? Well, a dentist uses a small concave mirror to get a magnified or enlarged image of your teeth. And the reflector inside a torch or a car headlight is also a concave mirror. It takes the light from the small bulb and directs it forward as a powerful, straight beam. And what about the convex mirror, the one that spreads light out? Because it gives a wider field of view, it's used as the rear view mirror in cars and buses, allowing the driver to see more of the traffic behind them. You'll also see large convex mirrors in shops and at sharp turns on roads for security and safety. So you see, understanding how light works is so important. It helps us understand how our eyes work, how cameras capture photos, and it is the foundation for so much of the technology that we have today. And that's really the main thing to remember. Light doesn't just help us see things. It is what paints our world with beautiful colors, powers so much of our technology, and fills us with a sense of wonder. So the next time you see a rainbow, I hope you'll remember the incredible science story happening right in front of your eyes.